I'm Carol Ann Riddell, and this is Science and You. The blue planet, one of our nicknames for Earth, reflects exactly what's needed for life, water. Lucky for us, about 71% of the Earth's surface is covered with it. Just how vital is water? Consider this. Right now, NASA's spacecraft Juno is studying Jupiter, including trying to determine how much water is in Jupiter's atmosphere. We'll have more on the Juno mission throughout the show. But first, let's start here at home with our oceans and what we know about how climate change is affecting them.
They are home to a rich diversity of animals, plants, and microbes, from the largest animal on the planet, the blue whale, to the tiny plankton that can only be seen under a microscope. The general health of our ocean waters depends largely on how we humans interact with it and with the environment in general. Oceana, an international foundation focused solely on the oceans, reports our oceans face multiple threats to their health due to pollution from oil spills, coal plants, and climate-changing gases. Every year, at least 8 tons of discarded plastic finds its way into the world's oceans, with deadly consequences for seabirds and fish. NOAA, the National Science Agency, reports that while there are no sound estimates on the size of these so-called garbage patches, marine debris does accumulate in several areas of the northern Pacific. We put it there, and nature, by way of the ocean currents, corrals it into islands of floating trash. Speaking of currents, a link has been established between ocean circulation and climate. It's the subject of a new study by scientists at Columbia University's Lamont Doherty Earth Observatory. Published in the journal Science, Jerry McManus, a professor of environmental science, along with lead author and grad student Gene Henry, detailed for the first time the impact of large-scale ocean circulation and abrupt climate change. While they focused on prehistoric times, there's a cautious concern for the modern era.
We have a saying in the earth sciences that everything that has happened can happen. The changes that Gene and our fellow colleagues have uncovered are much larger than anything that our society has experienced. None of those things will happen on a scale that we saw, but on smaller scales, they could still be influential.
Many of the current threats to the world's oceans go hand in hand with the problems of climate change. It's our job to keep them in balance. In their recently concluded assessment of the world's oceans, the United Nations General Assembly underscored the importance of our positive stewardship of the seas. The impacts of humanity on the ocean are parts of our inheritance and future. They've helped to shape our present and will shape our future. For Science and You, I'm Mike Gilliam.
We've heard a lot about rising sea levels and what that may mean for us. Lisa Beth Kovitz heads down to the Jersey Shore to learn more from engineers at the Stevens Institute of Technology.
Our changing world can be very confusing. Global warming, climate change, what does it all mean?
Let's try and sort it out. Global warming is the scientifically confirmed rise in average temperature worldwide, and climate change is how that warmer weather will affect individual communities.
Here in our section of the globe, one of the most significant elements of climate change is a continuing rise in sea level.
So, what exactly is sea level?
It's a simple question without really a simple answer.
Okay, so raise your hand if you thought sea level was measured by sticking a ruler in the ocean.
Turns out sea level is an astronomical calculation.
Essentially what it means is over 19 years, the sun, the moon, and the earth take all the positions they possibly can with respect to one another. And so if we take an average over 19 years, it gives us sort of a true average.
And on average, sea levels are rising.
Are rising sea levels all about storms?
It's not all about storms, but it's going to be the major aspect that affects us in this local area. We're going to see storms coming up to northern locations in the world. It's going to cause storm surge, higher tides, and we're going to see that water coming into the landscape that we haven't seen before.
The flooding we see is terrifying enough, but rising sea levels can also contaminate our drinking water.
Yeah, I mean, we are starting to see salt water intruding into aquifers already, particularly in areas where we've withdrawn water for drinking and for other reasons, pulling that water down and then it's being replaced by salt water.
If you've ever taken a drink out of the ocean, you don't really enjoy that very much.
Here in New York City, most of our drinking water is safe upstate in aquifers.
But New Jersey's water problems could quickly become our own because New Jersey grows a lot of our food.
You know, we're called the Garden State for a reason, where the two things we're famous for are pharmaceuticals and agriculture. I, for one, would like to see more farms and less pharmaceuticals, so.
There's no doubt that our region faces significant challenges as sea levels continue to rise.
But New York City is a tough place, and we've got a lot of good natural strengths on our side. For starters, New York City's got the schist.
Schist is a metamorphic rock that's already been subject to such high temperatures and pressure that salt water really isn't a problem for it. There's so much schist in Manhattan that we built our very own city college out of it. And even though we're made up of islands, a lot of New York City is actually on high ground. But not all of it. And a whole lot of our infrastructure, think subways, Con Ed, municipal tunnels, is underground.
But New York is New York, and our city is meeting the threat head on. The East Side Coastal Resiliency Program is set to break ground next year on the Big U.
The Big U is basically a giant levee built around the bottom of Manhattan.
On dry days, the levee will be covered with parks and bike paths, but underneath, it will be engineered to protect lower Manhattan from another storm the size of Sandy.
All of this is very political, and rising sea levels have put our New York and New Jersey scientists in new and complicated positions.
As an environmental scientist, how do you balance the dual responsibilities of raising the alarm and keeping people calm?
So you don't want to over-extrapolate out what might happen, because if we do it too many times, we cry wolf, people stop listening.
I always say that I sort of have the easy job because I have to, I can deal with the science, I can deal with the physics and the, you know, in some cases the chemistry and the, you know, biology and the engineering and what sort of what's going on. And so those processes are I would say, are well understood or better understood. You know, I feel a responsibility as a scientist to feed the information to those that can make these decisions. And you know, I say sometimes I got my PhD down at Florida, University of Florida, but I get my PhD in political science just from working in New Jersey and trying to understand the way that the system works. I feel my responsibility is to tell the truth, you know, the scientific truth in the, you know, the most easy to understand way that I can, and ensure that that's what's being used to guide decisions. Sounds really easy, but it's not.
Can we science our way through the oncoming troubles? There's no guarantee, but at least one local climate scientist is willing to bet her future on human engineering. I hear that you just bought a house that sits 5 feet above sea level. What were you thinking?
I ask myself this every single day as I'm looking at raising my house. There is a huge community at the Jersey Shore that you don't find anywhere else, or maybe you do, but once you're a part of it, you never want to leave there.
Do you think that we have the current engineering capacity to combat rising sea levels?
You know, I think we do. You know, I'm an engineer, so I'm biased. I always say that there's not a problem that we can't fix. Communities that, you know, are slow to react are going to drown slowly, and then the communities that are being more progressive and thinking outside of the box, making investments, you know, those communities are going to be the ones that have a better chance at long-term survival and viability. They're difficult economic decisions to make sometimes, but I think the smart communities will start to think more long-term and plan for sea level rise.
From the Jersey Shore, this has been Lisa Beth Kovets for Science in You.
5 years ago, NASA set out to discover the secrets of Jupiter, potentially allowing us to understand the beginning of our solar system. The Juno space probe was sent on a 1.8 billion-mile flight and has now successfully entered Jupiter's orbit, where it will study the gas giant's atmosphere, magnetosphere, and radiation belt. Now we take you underwater to learn about a source of clean energy. Ari Goldberg introduces us to a company working on a major development in marine and hydrokinetic power.
Verdant Power is a renewable energy company focusing on hydrokinetic power. What that means, hydrokinetic power, is having like wind turbines under the water using water currents to produce electricity.
So this is not hydroelectric power?
It is hydroelectric power, but it's unconventional hydropower. Conventional hydropower uses dams, and we do not use dams. So the reason it's more reliable is because water currents are very predictable, whereas the sun doesn't always shine, the wind doesn't always blow. It's as simple as that.
Verdant Power has established a pilot program off the shore of Roosevelt Island in the East River to harness the power of that current.
So from that buoy back to where I'm standing, we had 6 turbines under the water. In the future, we'll be putting 30 turbines in the water. So underwater generators create the power that are brought ashore with subsea cabling into this control room. And then it's delivered up these, you see these metal cables from the control room, It goes up there into Gristedes Supermarket and a parking garage, which is called Motorgate. So we were producing power for both the Motorgate parking garage and Gristedes Supermarket.
Powering the Roosevelt Island Gristedes and parking garage were all part of the testing phases for Verdant's technology. They were the first in the world to install these types of turbines all the way back in 2002 and connected them to the grid here to produce that power in 2007. But the regulations for new infrastructure technology are massive. On average, it takes 10 to 12 years to go from prototype to commercialization. Verdant Power has had to get approval from 23 different regulatory agencies, ensuring things like wildlife safety, water safety, navigation safety, in order to get a license and to commercialize the turbines.
It is easier to probably send a rocket to the moon than to get these technologies to work underwater. We have a license to produce 1 megawatt of power here in East River. 1 megawatt's 1,000 kilowatts, and as a rule of thumb, 1 kilowatt per household. So theoretically, there's enough power here to provide power for about 1,000 homes.
Now, I have to imagine that if it's taken 12 years to power 1,000 homes, is this really an efficient way to go about?
Remember, 12 years is to get the technology from working prototype to commercialization. Once it's commercialized, then this starts moving very quickly. And so we right now are examining sites all around the world. When you think about not only New York's East River and Hudson River and Long Island Sound for tidal power, but the Black River, St. Lawrence River, Niagara River, it's like 2 nuclear power plants just using water currents, and all underground, all underwater, so you don't see them.
Ultimately, the temporary control room here will be phased out as all the cabling will run entirely out of sight under the water to power the island. It can even integrate into existing technologies to make them better too.
If you think about it, where the dams are built, you could also put these downstream of dams to capture otherwise wasted energy. So for example, with climate change, river flows all around the world are going to begin changing. Some rivers are flowing less, some will be flowing more. So the idea of placing these even downstream from the dam, it would be adding capacity to capture otherwise wasted energy. So they could work with dams by adding additional power. The world moving from central power to decentralized power. It's the idea that the world's also moving towards what's called microgrids. Microgrids, and this is what New York is doing ever since Superstorm Sandy, what grid resilience is all about is to create sustainable communities within the city. And that becomes a microgrid using local indigenous resources to power it.
Microgrids protect against catastrophe because they wouldn't be entirely dependent on a city's central power. Roosevelt Island could soon be powered entirely by hydrokinetic power, effectively making it its own self-sustainable microgrid. Despite sea swells and surface winds of storms and tides, the core current of waterways stays largely consistent, right where the turbines are placed. So even in events on the scale of Superstorm Sandy, turbine-powered microgrids should maintain power.
But let me add one more thing to it too, about applications, because I mentioned this. The tidal power could be, in this parking garage, could be recharging electric vehicles. So wouldn't it be cool if New York City had tidal-powered cars zipping around its streets?
And if that wasn't enough, while the rotors of the turbine are channeling water through an electric generator, they can move that water simultaneously for other purposes as well. Be that through reverse osmosis filters to actually clean the very water it's in, to pumping it on land for irrigation, or sucking it back after flooding.
So it's that part of that water, what we call the water energy nexus. Water uses energy, energy uses water, but our systems are being to use it cost effectively and efficiently.
And as Verdant clears the final technical and regulatory hurdles, this technology can be exported all over the world, providing sustainable power globally and jobs to New York.
Right across the way from us is it's called Ravenswood. That power plant produces 25% of all of New York City's electricity. And so that represents where we've been, and Verdant Power represents the future of where we're going.
From the East River to your home and the world, I'm Ari Goldberg for Science and You.
On top of there being this climate change that affects the different physical parts of the Earth differently, in those places on the Earth, there are lots of different ways of understanding the Earth. In the West, we tend to focus on science, data, measurement, computer modeling, etc. In the majority of other cultures in the world, there is much more of a dependence on beliefs and understandings that have to do with the natural world. The natural world is nature-filled. We are part of it, right? And so to get under the skin of the people who are really feeling these frontline effects of climate change, it's important for us to understand how they're perceiving what's going on.
The key to all species enjoying the planet is to coexist. Andrew Falzone finds out how sea life creatures, plants, and humans all live together here at the Hudson River.
Almost 20% of the world's known species make their home in water, and here at the Liberty Science Center, the Hudson River exhibit explores the relationship between all of the animals in the ecosystem, including us.
And we are starting to see a lot of other species beginning to maybe return.
And Fred Hartman of the Liberty Science Center says that's one of the indicators that the Hudson is a river on the rebound. On display at the museum are some of the river's native inhabitants.
The biggest guys we have behind us are our black drum. They're the largest fish. They have kind of some whiskers dangling from their chins. Those are actually called barbels, and they taste with those. The other fish that you might see, we get a lot of people call them the angelfish. Those are called permit. And they're a seasonal visitor to the Hudson River. But during the summer, they'll come on up. They're a schooling fish. They have a really cool compressed body like that classic angelfish might. And that's actually a way that allows them to maneuver really quick. So that's a fish that they're pretty fast, but when they want to turn, they're really, really quick at turning.
The Hudson River is also an active waterway with 73 million tons of cargo passing through each year. The value of that cargo is over $200 billion. The gigantic ships that roll up and down the river are actually quite efficient.
The other side of this story is it is better to have one enormous cargo ship come in with all this stuff than hundreds upon hundreds of trucks or trains. So it's actually the more ecologically friendly way to move this stuff is by one big ship rather than all these other things.
The exhibit includes a crane simulator where even the smallest hands can try unloading cargo from some of the world's biggest ships. And while the open water of the Hudson hosts these gigantic ships, some of the river's back channels provide safe harbor for some of its smallest fish.
Salt marshes are great spots for fish to come and have their young. So a lot of the fish you might find in a salt marsh, like a lot of the fish you're seeing right here, are not permanent residents. They are temporary visitors. They either come here during certain times of the year to grab a quick snack, or they're born here. And this is a great place for them to grow up. They can be well protected from many predators.
The Hudson also caused significant flooding during Hurricane Sandy, like this scene in the Lower East Side of Manhattan. Understanding the river's tidal zones help us understand potential flooding, and each zone is described in detail. Also on display is a giant core sample, which allows scientists to learn about the history of the river going back a few thousand years.
Core sampling is that window down to show you what plants were here, what the temperature might have been like. What stuff was in the atmosphere, and that kind of gives you an idea of how time's changing because it gives you a comparison to where you are now.
The last stop in the exhibit is a touch tank filled with sea urchins, sea stars, and horseshoe crabs.
I guess in an exhibit where you're really trying to tell the story of an ecosystem, this really makes that connection come alive.
Absolutely. So you've made your way through the Hudson River, our Hudson River Gallery. You've seen the river, you've seen the animals, you've seen the human impact, and now you're having an impact. And this animal's now having an impact, maybe even more so on you. And maybe as you've seen all these things and start to realize it's not just that thing you kind of drive over every day on your way to work. There's an entire ecosystem going on here, and we're all part of that.
I'm Andrew Falzone for Science and You.
Now that Juno has reached Jupiter, it will orbit the planet 37 times over a 20-month period. After Juno has completed its mission, it will deorbit by falling into Jupiter's atmosphere and burning out. NASA wants to avoid any possible contamination of Earth microbes on Jupiter moons with the potential of supporting life. From too much water to not enough, our next story deals with the subject of droughts. They can be a harsh aspect of life, but also managed effectively with scientific planning and foresight. Donna Hanover has more.
If you look back hundreds and thousands of years, you see that there are many, many larger, more sustained, more intense droughts. We see episodes of substantial drought that in the West has lasted for several decades, and in some cases more than 250 years.
City College of New York professor Charles Voris-Marti, director of the Environmental Crossroads Initiative, says droughts in the West occur because the winds that bring water vapor from over the Pacific Ocean sometimes move more northerly than usual, so places needing rain and snowfall to fill up rivers and reservoirs don't receive it. For the last few years, people in the western U.S. endured water restrictions in their homes and cities, and farmers were allocated less water for their crops. Meanwhile, drought conditions enabled more huge wildfires than usual and made fighting them much harder.
With diebacks in some of these forests, in the propensity of insect species to come in and to invade these forest systems, and weaken the forest systems, means that the firefighters are going to have a tougher time because the forests are weaker, they're unable to process water and the chemicals that they need to survive, and before you know it, you have these tinderboxes that are developing.
Californians cheered this winter when the weather system that comes in from the Pacific was an El Niño, bringing in more rain and also snow that can melt over time to fill the rivers and reservoirs. But the snowpack is melting quickly, and there wasn't enough rain to refill underground aquifers. Dr. Voris-Marti strongly suggests adjusting agriculture to crops that require less water.
Matching the kinds of activities that you would have within a state or a locality relative to the long-term water supply seems to me to make much better sense than simply looking at what might yield the most quick profit for those who are involved with these kinds of activities.
Should we expect a drought in the Northeast?
These atmospheric distortions that are creating problems for the West and that have occurred time and time again in the West have also occurred in the East. The largest drought that we can refer to in the recent past was that which occurred in the early to mid-1960s. We're on the 50th anniversary of that particular drought. I grew up in that drought here in New York City. This 5 or 6 year intense drought that we saw in the 1960s here in the East Coast, here in New York City, it had an impact on agricultural systems. There were water bans, and it was becoming a dire situation until the drought broke. However, in the intervening 50 years, we've done a pretty good job of reducing, for example, the per capita water use in the domestic water supply, so that on average you and I are using 40% less than we used to use. For example, could install toilets that save more water, plug gaps and leaks in the system. We've had a sequential move towards much more efficient power production from our electric power production stations. Replacement of the old coal-fired power plants to much more efficient, what we call dual-cycle gas-fired plants. They're much, much more efficient, so they require much, much less cooling water. We also had a restructuring of the economy during that period of time. So whereas we were producing a lot of products like steel, for example, and heavy industry that were water consuming, we moved more towards a service society.
You know, some of these places that have drought, you look out and there's the whole ocean. Why not desalinate some of the ocean water?
That, in fact, is happening in parts of the world. Desalination is a very interesting and wonderful technology that, at least on paper, looks as though it's going to bail us out of otherwise dire situations. And that's a great solution for those who are willing to pay for it. Right now, it's the most energy-intensive and expensive way to produce fresh water. You could do a better job recycling water that's been used and cleaning it up rather than taking salty water and creating fresh water out of it.
Professor Voris-Marti says many people in the developing world are especially hard hit by droughts that bring famine because they don't have the resources to build dams and reservoirs or water treatment plants. He says using natural ecosystems is one answer.
You could get good clean water supplies so that you don't constantly have to be building expensive water treatment facilities to clean up polluted water. A great example of this is the New York City watershed in the Catskills, where we specifically protect that watershed to reduce the cost of treatment for water that comes into New York City.
What is his primary message on drought?
What it really boils down to is people not really living within their water means. One of the things that we have to be thinking about is matching the sustainable water supply that we would see versus the usage. It's a very, very precious resource.
The bottom line is it's better to get smart about planning for drought conditions before they arrive. I'm Donna Hanover for Science and You.
My recommendation is not to change your light bulbs, but rather to what I call relocalize your life. What happens is people build community. You start knowing who the farmers are and who's producing your food, and you start to reestablish that intimate connection of community that we have had in this country in our grandparents' time.
That's our show for today. Join us next month when we highlight some of the major contributions women have made to science. I'm Carol Ann Riddell. Thanks for joining us for Science and You.